then that's actually very hard test. A uniform meter stick. So we know the total loss will be 1 meter for this one because it's a meter stick. So it's 1 meter, and then we know there is a 25 centimeter place. There is a horizontal axis. It's like this. So if there is an axis, if you put it here, this will fall. The meter will fall, will rotate like this, right?
Like something like that.
So it's
Like if you had a ruler.
It's like this. You hold this.
And it falls. Okay.
Yeah, it will fall. Okay, that's the first thing. And then they tells you if there is a rod in the middle, which will be 50 centimeter place, right? If it's in the middle, the moment of inertia will be 1/12 ml squared. But right now it's not in the middle. It's in 1/4, 25. Okay. So the first thing you need to do is to calculate the moment of inertia for this one, if the axis is here. There's one equation. You learn in the class? You learn this one?
Yeah.
Okay. So you know that in the center, right? And then M should be the same M. The distance here, you know, is 25 centimeter. Just remember to put into meter, 25 squared. Right? That's what you got. And this L is 1 meter. So it's 1. L is 1, right? Because the total loss is 1. So it's 1/12 times M plus 1/16 plus M. If you calculate this, need a calculator to do that. Okay, that's the first thing we got is the moment of inertia, right? So you understand here?
How do you get 1/16?
Oh, it's just you need to use a calculator to calculate it. Because 0.25 is 1/4. 1/4.
Oh, okay, you just don't.
Yeah, I just do these.
Okay, all right.
But if you use a calculator, you can get
Right.
the number. It's the same thing.
Okay.
So, so you can calculate here, and
Yes.
you got this I, and that's the first step. And then you need to analyze this meter. Okay. So here is 25. Here is 1 meter. 25. And then we need to analyze the force. Here is the mg. Here is a mg. Torque 1, torque 2. Okay? So actually we use the same thing. Torque 2 minus torque 1 will be moment of inertia times acceleration. Sorry. Times the initial angular acceleration, right? So we just need to plug in the numbers. The thing you need to remember is T2 is M2G. M2G, and what is R? It's here, right?
Mm-hmm.
The first thing you need to know is the center of the mass will be in the middle,
Mm-hmm.
right? And here is 0.75. So here will be 0.375. That's the R.
Oh, because it would be
In the middle.
in the middle.
Yes. Because here, the center of the mass will be in the middle too. And then here will be the R will be 0.125. It's the center, it's a half of the 0.25. Right? Because you want to calculate torque 1, it will be the force times the distance between the force to the center, to the axis.
The way I looked at it is I just look at it as like hundreds. So you go, it'd be 25 from 25 to the end, and it'd be 0.75
Yeah,
because that would be 100.
yeah.
And from T1 to T2,
You need to analyze T1 and T2 individually, separately.
right? From T1 it'd be 0.75.
From T1, it's in the middle here.
I'm saying T1 to the end. From T1 to
To the end.
end, it would be 0.75. Right?
First is you don't need to.
So why
that.
did you put 0.75?
T1 is from the axis to the end is 0.75.
Right. That's what I was saying.
But the T1 is not in the axis. So the weight here is not in the axis. In the axis, you don't have any. The weight is in the center of.
But
it's
we're
in the-
we're trying to calculate the R, is what I'm saying.
Yeah, we're trying to calculate the R.
That's what I'm trying to figure out how to
So-
calculate.
You need to see it as two objects. So the first object is here, the left side. And the second object is the right side. There are two sides.
Mhm.
So here is what I call M1, here is what I call M2.
Mhm.
Apparently you know it will go this way. It won't go this way. Why? Because here is heavier.
Yeah.
There are more mass, and then it will go here. And then the second step is we need to find the center of the mass. For M1, where is the center of the mass? It's in the middle, right? The gravity will be like this.
Mhm.